Alright guys, so let's talk about equilibrium reactions. An equilibrium reaction is another way of describing a reversible reaction. So, chemical reactions can go to completion, or they can be reversible. Now, a reversible chemical reaction in a closed system, go back and forth, okay? Instead of just going from reactants over to products, they go backwards and forwards. So, you'll have some reactants changing into products, but you'll also have some of the products changing backwards into reactants. And eventually, if it's in a closed system, it will reach an equilibrium. So let's have a quick look here, and we'll see what that means. This is a really common example, and this is the dissolution or dissolving of carbon dioxide into water. And it gives you, the product is carbonic acid. Now, this should be a G. So if this is our reactant side, and this is our product side, if this reaction reaches an equilibrium, and we'll do a whole video on this reaction alone, if this reaction reaches an equilibrium, this doesn't mean that it's smack bang in the middle because I said it's going forwards and backwards at the same rate. What it actually means is that it might be mostly, so the reaction's equilibrium might be here. So this is concentration. So in our solution, the concentration might be mostly products. Oh, sorry, actually, this is what I say. It must be mostly reactants and only a small percentage of products. Now, that's fine. That can still be an equilibrium because what it means is this reaction is, so some of these products are changing that way and some of the reactants are changing that way, but the concentrations won't change. So every time products go this way, more reactants go this way in the same rate. Okay? So an equilibrium means they're happening at the same rate. So if an equilibrium is reached, we use the simultaneous forward-reverse reaction symbol. And that's this one here. And that's why we're not using this one to describe that. And that's because the reaction is happening at the same rate, forwards and backwards. And this is why you'll get a constant concentration. So a common examples of this are dissociation of weak acids and weak bases. Okay, these are commonly equilibrium reactions. So let's have a look at what chemical equilibrium actually is. As we said, reversible reactions in a closed system can reach equilibrium. There are several conditions that need to be met for equilibrium to occur. So you need a closed system. What this actually means is no energy or matter is going in or out. Now the chance of getting a perfect closed system is really quite not happening. Constant macro properties. This is your color, pressure, temperature, all the ones which are really easy to see. So the macro properties become really constant. The concentrations of the products and reactants are also kept constant. This is when it's in equilibrium. Okay, so you're in a closed system. The macro properties are staying the same. The concentrations of your products and reactants are kept constant as well. The forward and reverse reaction occur at equal rate. Now, this keeps the concentration the same. As one product is formed, one reactant is formed. Now, this doesn't mean, again, you have equal products and reactants. Not at all. It just means that every time a product is formed, a reactant is formed in the opposite direction. Alright, I hope that made a lot of sense. If you have any questions, feel free to ask them in the comments below, and we'll get back to you as soon as we can. Thanks for watching. Bye now.